Today I want to explain OpenClaw in plain business terms. Think of it as an AI operator that runs on machines you control, not just answering questions, but executing real work. In the next few minutes, we will cover what it is, how it works, and what safe adoption looks like. Quick context first. You may hear three names: Cloudbot, Moltbot, and OpenClaw. They point to the same open source line of work. What stayed stable is the philosophy. OpenClaw is built to execute tasks on systems you own. And once something can act, governance becomes a first-class topic, not an afterthought. Here is the simplest definition. OpenClaw is a self-hosted execution agent. It runs on machines you control, like a laptop, a virtual machine, or a server. It can read and write files, run shell commands, and call APIs. And it is persistent, meaning it can remember context across sessions and chain steps over time. This is the first big shift from chat tools. It is designed to do work, not just talk about work. This is the boundary line to remember. Chatbots are conversational. RAG systems retrieve knowledge and write an answer. OpenClaw crosses into execution. If you ask it to find files, extract insights, and save a summary, it does not describe the steps. It performs the steps on the machine it is running on. That is powerful. And it is also where the risk comes from. Once you move from advice to execution, you unlock real leverage. You can automate repetitive work, tighten onboarding, and reduce operational toil. But the trade is clear. You now have an agent with access to systems and data. So the right mental model is a privileged service account, with rules, logs, and approvals. A smart rollout follows a maturity path. Start in a sandbox, add controls, then scale. This diagram is the practical way to understand OpenClaw. It runs as a persistent agent, not a stateless chat session. Humans connect through a gateway like Slack or a command line. A reasoning layer uses an LLM to break work into steps. Those steps are executed through a skills layer. And the memory layer stores long-term context in local markdown files. This design is headless by choice. It avoids fragile screen automation. Layer 1 is persistence. Most chat systems treat every message as a fresh start. OpenClaw keeps running and keeps context. That enables it to chain tasks across days, remember decisions, and avoid repeating setup. In practice, this is what turns AI into a reliable operator for repeatable work. The flip side of persistence is that mistakes persist too. If the agent picks up a wrong assumption, it can repeat it. If we grant broad permissions just to get started, that can become the default forever. So the control mechanism is simple. Treat corrections like change management. Update the instructions, review the logs, and validate the behavior over time. Layer 2 is the gateway. It is where people talk to OpenClaw, often through Slack, Discord, or a command line. This layer ingests messages, authenticates users, routes instructions, and formats responses. From a security point of view, it is often the largest attack surface. So it must be treated like a production access control system with strong identity, allow lists, and audit logs. Layer 3 is the reasoning layer powered by an LLM. It interprets intent, breaks work into steps, chooses which skills to use, then checks results and iterates. This is what makes OpenClaw feel adaptable, not brittle, but it also creates uncertainty because LLMs are probabilistic. So we need guardrails, constraint tools, approvals for risky actions, and safe boundaries by design. Layers 4 and 5 are where work becomes real. Skills are the control tools, file operations, shell commands, APIs, GIT, and scripts. The key idea is that skills are the boundary between AI and the system. If the skills are too permissive, risk goes up fast. Then memory. OpenClaw keeps long-term context in local markdown files, including task summaries and action logs. That is great for transparency, but only if those files are secured like any other sensitive operational record. A practical detail. OpenClaw is intentionally headless. It does not click around a user interface. It works through commands, APIs, and files. That makes it faster and more reliable, especially on servers. But it also reduces visibility, so teams need to compensate with strong logging, monitoring, and audit trails. This table makes the differences concrete. Chatbots are low risk because they mainly produce text. RAG systems add document retrieval, so the risk is moderate. OpenClaw adds execution on systems, so the risk profile is high. The key takeaway is not that one replaces the others. They are complementary. Use the right tool for the job, and apply governance where execution is involved. This is the risk story in one phrase: shadow superuser. OpenClaw runs under an account and inherits its permissions. If that account has admin or root access, the agent effectively has full system control. That raises the stakes. Prompt injection can turn into command execution. A misconfigured gateway can become a remote control channel. And weak logging means we may not notice until damage is done, so least privilege is not optional. It is the starting point. Now the practical question: where does this help in the real world? First, developer onboarding. Instead of a brittle checklist, a new hire can interact conversationally, while the agent executes the steps consistently. Second, DevOps housekeeping. Tasks like log rotation, disk cleanup, updates, and backup verification can be delegated, with summaries and logs. These are high leverage because they are repetitive, and mistakes are costly. 3 more use cases are especially relevant at scale. Incident triage is a great fit because the agent can gather evidence quickly. But remediation should follow strict playbooks, not improvisation. Next, internal tooling and glue code. OpenClaw can orchestrate command line tools and move data between systems. And finally, personal workflows like organizing files, generating reports, backups, and research summaries. In each case, the pattern is the same. The agent turns intent into repeatable action. OpenClaw creates leverage, but only when the organization is ready. On the technical side, you need basic shell literacy, secure deployment practices, and strong observability. On the organizational side, you need governance, approvals, centralized logging, and security partnership from day one. When teams skip these basics, the technology does not fail. The deployment fails. Here is a simple decision framework. If you are early, learn first in a sandbox with dummy data and security involved. If you have strong DevSecOps maturity and real customization needs, build. If you want lower risk and more guardrails, buy. Across all paths, successful deployments look the same. Clear scope, least privilege, strong observability, measurable value, and disciplined change management. Let me close with the headline. OpenClaw is a shift from advisory AI to operational AI. That shift creates real leverage, but only with discipline. When deployments are casual, the agent becomes a liability. So the differentiator is not model intelligence, it is governance. A practical next step is a short sandbox pilot with least privilege, full logging, and one high-value workflow.